Hello Year 7, it's Ms Redmond here again with your fifth and final summary PowerPoint for the forces topic. If you haven't got one already, please stop the video and go and get a pen so that you can take notes and do any of the little tasks that I give you as we go along. The title for this lesson is What Happens When Forces Are Balanced or Unbalanced. So it's all about balanced and unbalanced forces. Here are your success criteria, so feel free to pause the video now and write those down. Your DNA is, why is it important for future scientists to learn about forces? So pause the video now, write down your ideas, and you can email those into your teacher if you want to check them. When the forces acting on an object are the same size but in opposite directions, they are balanced and the object is in equilibrium. So the example that I've got here is a tug of war. So if you look at this top part of the diagram, this team is pulling to the left with a force of 300 newtons, and this team is pulling to the right with a force of 300 newtons. So those forces are the same size, 300 newtons and 300 newtons, but they're acting in opposite directions, left and right. So the object, I guess in this case you'd say that the tug of war rope was the object, is in equilibrium, and those forces are balanced. And we'll talk about this part of the diagram a few slides later. Here are some examples of balanced forces. So we've got some chocolate milk that's spread over one of the ping pong tables out near the cafeteria, and it's got to the edge and it's stopped moving because the surface tension of the chocolate milk is exactly balanced with gravity and it's not going anywhere. These forces are balanced. This kid is sliding along on the ice and the force of her, presumably she pushed off with her legs, so the force of the thrust from her legs is exactly balanced with the force of friction on the ice and air resistance. So she's moving, but she's moving at the same speed. So the forces on her are balanced. These hair straighteners are sitting on the carpet, so the weight of gravity pulling them down is exactly balanced with the reaction force of the carpet and the floor pushing them upwards. Don't do this, by the way, because if you leave your hair straighteners on the carpet, or even worse on your bed, you could be in serious trouble. Here's another example of balanced forces. So this, what do you call it? Skydiving. This skydiver has jumped out of the plane and they've opened their parachute. So the force of gravity pulling them down at the moment is balanced with the force of air resistance pushing them up again, and they are falling at a steady speed. So they're not changing speed or direction or shape. They're falling at a steady speed and the forces on them are balanced. Alright, so to unbalanced forces. If the forces acting on an object are not the same size, they are unbalanced, and the object is either changing speed, changing direction, or changing shape. So this is coming back to something we mentioned in the first lesson, right? The effects of forces. Forces can change the speed, direction, and shape of objects. So talking about unbalanced forces, if we look at the bottom part of this diagram, this team on the left have suddenly gained some more strength from somewhere and they're now pulling with a force of 400 newtons, whereas the other team is still trying to pull with a force of 300 newtons. So the forces, even though they're still acting in opposite directions, this force is much bigger. So they're no longer in balance, the forces are no longer balanced, and the object is no longer in equilibrium. The tug of war rope is going to go to the left and all of these people are probably going to fall over. So those are unbalanced forces. And here's some more examples of unbalanced forces. So this tennis ball, if we focus on the ball, is changing speed. It's probably slowing down at this stage in its path. It's probably changing direction if the other player put a bit of spin on it. And when Serena hits it with her tennis racket, it's going to deform because it's going to change shape. It's going to change direction. It's going to be going a lot faster because she hits really hard. So the forces on this tennis ball are going to be unbalanced. Here's a diagram form with arrows showing the forces. So we've got the space shuttle on a rocket, and the thrust from the rocket's engine is the green arrow, and it's much bigger than the weight of the rocket and the space shuttle. So they're unbalanced. They're acting in opposite directions. Weight is pulling down and thrust is pushing up, but thrust is much bigger. So those forces are not balanced, they're unbalanced, and the rocket is going to accelerate, it's going to change speed in the upwards direction. Here are some other balanced forces. So we've got a roller coaster car. It's just come to the top of this loop, so it's just starting to accelerate or change speed going down the track, because the force of gravity, or the force of the weight of all of the roller coaster cars, is greater than the force of friction between the track and the roller coaster, and it's greater than the force of air resistance against the roller coaster cars and all the people having a lovely time. And the force on these football players are also unbalanced, because the force of thrust from their legs pushing them forwards is greater than the force of friction between their shoes and the ground, and the force of air resistance between their bodies and the air particles that they're pushing past. Here's a specific example of unbalanced forces. So this is thrust SSC. It's a really fast car. It's more of a plane that goes along the ground, really. And the driving force from the engine is much bigger than the resistive forces of air resistance and friction. So sometimes we group air resistance and friction, and I guess water resistance, together and call them resistive forces. Sometimes we also call them drag. So you need to be familiar with all of those words. So they're resistive forces because they're resisting the driving force of the car, right? They're slowing the car down. They're acting in the opposite direction to the direction of travel. Here's another example of unbalanced forces, but in this one, the gravity of the Earth pulling the moon towards it is changing the moon's direction, but not its speed. So the moon is travelling, use my mouse properly, the moon is travelling along this blue line on its orbit. We'll talk more about orbits in the space topic. And the gravity of the Earth is changing its direction because it's going around in a circle, it's not going in a straight line, but not its speed. So this is an example of unbalanced forces changing the direction of an object. Here's an exam question. Your task is to copy the diagram below and label one of the arrows with weight and the other one with reaction. That should say reaction force, really. And then you've got 4 other questions. Please can you pause this PowerPoint slide and write down your answers to those questions. The next slide is going to be the correct answers. Here are the answers to those questions. So you're asked to label the diagram. The arrow pointing down is weight, and the arrow pointing up is reaction force. Part 2, the other force in the interaction pair is the force of the table on the lamp. You could also say it's the reaction force. Number 3, the forces on this lamp are balanced because they're acting in the opposite direction. Weight is pulling down, and reaction force is pushing up, and they are the same size. You can see that from the arrows, and you know that because the lamp is not moving. Question 4, the other forces acting on a car driving along the road include friction between the tyres and the road, thrust from the engine, you could also call that driving force actually, and air resistance from the car bashing against air particles as it drives along. And number 5, the forces on a car driving at a steady speed on a straight flat road are balanced. The clue is this part, steady speed. That means the speed is not changing. If the speed is not changing, and the direction isn't changing because the road is straight, then the forces acting on the car must be balanced. And your summary. When the forces acting on an object are the same size but in opposite directions, they are balanced and the object is in equilibrium. If the forces acting on an object are not the same size, they are unbalanced and the object is either changing speed, changing direction, or changing shape. The driving force from the engine of thrust SSC is much bigger than the resistive forces of air resistance and friction. So this is about resistive forces slowing things down. And the force of gravity from the Earth changes the moon's direction but not its speed, because it keeps the moon in its orbit. Thank you very much for listening, and I will speak to you next time.